Because that's more time for more derivatives. Oh wow, the heat had to turn on now. Guess they knew we were doing logarithmic differentiation. So we know that e to the log x equals x because the logs would cancel. We get x. Now, if I differentiate that, derivative to dx, e to the log x, I'll just get the derivative of that equals 1. But, well, I guess on the other side. Okay. So they're setting them equal to each other. Very cool. So we're differentiating both sides. Okay, we get 1, so then we get e to the log x times the derivative log x, because that's a function, sure. So that means this is x, because we're just equating the two, that e to the log, yeah, my bad. So we're equating these two, and then we're differentiating both sides to come up with this special sauce of how the derivative of log x of this thing is derived. So yes, I took the derivative of both sides, that's 1, that's e to the log x times the derivative of the argument, which is log x, divide both sides by x, so the derivative of log x is indeed 1 over x. That is the answer. Well, it's what we're going to use moving forward. The derivative of log x is 1 over x. Now, let's do some examples, because it wouldn't be fun if we didn't do examples. 15 lectures. So, if I have f of x equals ln of 3x squared plus 2, then really, pretend it's like g of h of x, right? In fact, g of x would equal ln x, and then h of x equals 3x squared plus 2. Yay, isn't that super motivating? Well, guess what? Using chain rule, I know g prime of x would equal 1 over x, and h prime of x equals 6x. So by definition, I would just do 1 over h of x times 6x, because it would have been g prime of h of x times h prime of x, right? Which is this. That would be the derivative. In fact, to write it a little bit better, I guess, if that's the word, you get 6x over 3x squared plus 2. That's what you would get. Okay? Whoa. Alright, that's fun. Let's do quotient rule example. Am I up for that? Why not? Let's freaking get it, man. Let's freaking get it, guys. God darn it. Freaking quotient rule. Ooh, I'm just kind of going fast. Oh yeah. Clean, just clean, bro. Clean slate. Boom. Done. Low D high minus high D low all over low squared. That's what we get. What about logs with a different base? Well, we know our change of base formula from back in the day, guys. I'm even going to write on this board right here that if you have a log of a of x, that's ln of x over ln of a, that's a change of base. So you differentiate log of a to the x, you get 1 over ln a times the derivative of ln x. In other words, because you would have done, oh yeah, because that's a number right there, so you'd put that in the front, times the derivative of ln x, and formally we would, for the notes, we would say, guys, that the derivative of log of a to the x is equal to 1 over x ln a. That's it right there. Right, guys? So if you have a product rule of 2x times log base 2 of x squared minus 2, if you just have leaf that 1 over x squared minus 2 ln 2 times the derivative of the inside, which is 2x, all of that plus 2x ln 2 times log that's so informal, but I didn't have enough room, so I put an arrow, but these would be beside each other. So you would basically get 2x, yeah, ln 2, yeah, plus 2 to the x times 2x, yeah. So you get something in the ballpark of this. I don't know why I switched the order in the notes here, but done. But halfway through. Wow, now we're talking about the fancy topic. Logarithmic differentiation. Isn't that fun, guys? Logarithmic. So we know how to differentiate f of x to the n. You can change power rule, yeah. So what if we have f of x to the power of g of x? Oh, I get it. So like, what if we had like f of x as like 3x to the power of 2x squared plus 1? Or like ln x to the power of ln x, right? Like, how would that end up, right? Like, that's a little ugly. Like, it's not e to the x, or like, it's x to the x. Like, that is disgusting, right? So, we have to do what we call logarithmic differentiation. Logarithmic differentiation. Let's do some steps. So, step one. Okay, how many of those? 3. Example is f of x equals x to the x, right? So you go, 1 is take ln on both sides. So you have ln of f of x equals x ln x, okay? And 2 is differentiate both sides. So you have d dx ln of f of x equals, go to this side, which is a product rule. Which is ln x plus 1. Now, f prime of f of x. Okay, yeah, because you go, derivative of this is f prime over f of x equals ln of x plus 1. Why is this the case? Because the argument is f of x, and then you'd multiply by a derivative of the inside, which is f prime of x, which is why, because the derivative of 1 is 1 over x, right? Then you go 1 over f of x times f prime of x. So now to solve for f prime of x, right? We go ahead and multiply both sides by f of x. So f prime of x, and I don't have any space there, so it'd be f of x times the ln of x plus 1, basically. So then, but f of x we defined as x to the x. So I could write my answer as f prime of x is equal to x to the x times ln x plus 1. Because you solve for f prime of x, you multiply both sides of f of x, right? So that is a freaking beast. Nasty. So if I do this again, this logarithmic differentiation, which is a mish and a half. Such a mish and a half every day. Running through the 6 with my woes. So if I have f of x equals x squared plus 1 to the power of e to the x. I ln both sides, I'm just following the formula. Differentiate both sides, solve for f prime. Ln of f of x, ln. So differentiate both sides, I get f of x over f, well, f prime of x over f of x equals product rule over here, which would be e to the x ln x squared plus 1 plus e to the x over x squared plus 1 times 2x, essentially. So then f prime of x equals f of x, all multiplied by e to the x we factor out the e to the x out of all this, so ln of x squared plus 1 plus 2x over x squared plus 1. So then you get x squared plus 1 e to the x times e to the x ln x squared plus 1 plus 2x x squared plus 1. Nice. So that would be that piece right there. That basically wraps it up with logarithmic differentiation. Sweet. All right, cool.